Okay, let's try this question here where they tell us that ST and VT are tangents to this circle with R, S, and V on the outside of the circle and WT and RV being parallel lines. And they tell us that S2 is X. They want to find three other angles equal to X. Well, there's tangent, there's the chord, there's the angle in the alternate segment, R. So R must be X. Tan-chord theorem. There we go. Now we know that these are two tans, so these two sides must be equal because tan's from the same point. And that means V3 must equal this X because of angles opposite equal sides. And then we get W3 equal to X. And why is that? Because W3 and R, with these parallel lines, are corresponding. WT parallel to RV. There's our three angles equal to X. And you know what we've got here? We've got W3 and S3 opening up to ST, the same line here. That means there must be a circle that could pass through WS, V, and T. It must be a cyclic quad, and it's the converse of angles opening up to the same segment. There you go. Now let's prove that WRV is an isosceles. WRV is an isosceles triangle. Well, if we could get V1 being X, we'd have it. So how could we do that? Well, let's try. W2 must be X now because we know this is a cyclic quad, and W2 and S2 open up to VT. Well, now we got W2 is X. Well, V1 is X because, hey, two parallel lines here. Those are called alternate angles. Well, now we've got V1x, Rx. It's got to be isosceles because those would be equal sides opposite these equal angles, which would make it a nice isosceles triangle. All done.